Okay, welcome back, everybody. We had a question right at the end of the last session. It was about, before we get into the, Jay, can you not share your screen right now? We had a quick question at the end of the last session on the rock boots and how this little Velcro piece works. This is going to be kind of hard on the background that I have. So let me just quickly just make this a little, make this a little easier for you guys to see this. With my curtain, my shower curtain, but it's way easier to see what's going on here for a second. So the question was, how does this little Velcro thing work with the rock boots? And by the way, not all the rock boots come with a hole through the bottom. These were for one of the mannequins. But the basic concept behind why there's this long lace, it actually allows you to open up the boot to its full expansion width, so you can get your dry suit sock inserted inside the boot. Once your foot's inside the boot, you'll pull this tight. You take the barrel lock, and this pulls down into the boot like so. The idea is then you take the flap in the back of the boot, and this will be in the up position. And then I will go around the entire boot underneath the flap, a full 360. Then I'm going to take the Velcro portion, and I'm going to adjust that so that it matches up exactly with the hook portion, like so. And I have the extra lace here. The flap on top will then come back down onto the pile, so it hooks that into place. All this extra lace, what I will do at this point in time is I will make a new knot at the appropriate distance from that point. So it now looks like so. Then I would take a scissors. I would cut this off, burn the ends or tape the ends so I don't have this extra lace dangling out from the rock boot. That way, then you still have enough length to get in and out of the rock boot, but yet fits perfectly. You don't have all this dangly bit. Okay. If you leave it and you tuck it into the boot like so when you're diving, I found that it usually doesn't stay there and it will come out sometime during the dive and be floating around. So it's best just to make a new knot and cut off the extra length. Okay. So with that, welcome back to the DUI virtual trade show. If you're just joining us now, we did start at 10 o'clock this morning, Pacific time. And we're going through our last session of the day, which is on public safety. And just to remind everybody that we will start again tomorrow at 10 o'clock on Pacific Coast time. So wherever you are across the world, just time that accordingly. And tomorrow will be primarily on the OMS product line. So it's if you never wanted to know about all this OMS gear that's out there, tomorrow we'll have Pete Nawrocky going through it and Thomas Dietrich of OMS talking about all the different products with OMS. So with that, I'd like to now have Jay jump back on. And where'd Jay go?
I'm here. Give me a second. I'm sharing screen.
Well, you have to start your video. You're not even on video.
Details.
Okay, so we have Jay back. Jay will be going through DUI and public safety. And throughout the presentation, we'll probably also get some help from Pete Nawrocky, helping with Jay on his presentation and certain points, because Pete also does this presentation all the time. So remember, if you need any of these one-on-one or actually these group presentations for your, in this case, your public safety dive team, please contact us at DUI and we will set up a custom Zoom presentation for your dive team. And if you're not public safety, we can set up for your dive group or your dive shop the same way. So Jay, go ahead.
All right, welcome to the public safety presentation. So in this presentation, we're mostly going to be talking about public safety. We're going to be talking about a little bit of the suits and why we would use certain suits in certain circumstances. So one of the first things that I know I'm not, there are probably some public safety divers out there. And I know this is kind of an open forum. One of the number one rules in public safety is everybody comes back. Okay, safety is everything. So going through this presentation, you're going to understand that, why we're wearing certain types of suits, why we're doing certain procedures. You're going to understand the difference between chemical and biological exposure. We'll go over that a little bit more in detail. We'll talk about how people mitigate exposure to using the proper equipment, understanding differences in the types of equipment, and being able to assess the dive situation, or to be able to assess the diving environment, so to speak. So we're going to go over through quite a few of these. The first things we're going to talk about is risk assessment. If you look to the right, those guys are wearing public safety suits right there. They're all in yellow. And then the guy below there is actually wearing one of our CXO suits with a full face mask configuration. I'll go into that a little bit more as we get through the presentation, but when we talk about risk assessment, we talk about proper equipment for public safety teams. What do they need to do to perform their dive operations safely? There is no way we can eliminate risk, right? I mean, there's always going to be some idea of risk. The idea here is to lower the probability of something happening, make things safer for the diver, safer for the operation, because that's really what this comes down to. So it's all about safety for the diver and understanding the different types of risks and evaluating your dive site. So you always want to conduct those evaluations and the risks of the dives. What are the goals? Dive technology, creating high standards for extreme conditions, require diving to assemble and meet the same high standards as a suit material for greater safety, and really use friendly and practical standards. Again, it's all coming down to safety, and it all comes down to what I just started with, is everybody comes back from a dive operation. The safety of the diver is of utmost importance. So the scope of the standards out there in public safety. One was we're limited to the dry suit. No other equipment is included. Does not include breathing systems, as that in NIOSH jurisdiction. Does not require ease of decontamination or mention of decontamination in any way. And it does not include testing for all contaminants. It's impossible to do. We cannot really test everything that's out there. But we can still develop suits that actually protect you. And we're going to start to go into some of those a little bit down the road. What do I do here? Okay, so design requirement. Well, we're going to talk about full encapsulation. What does full encapsulation mean? Within our dry suits, the CXO, the H2O, and the public safety TLS 350, you have the opportunity to wear a latex hood with that suit. You have to wear a beanie, or we call it a beanie for lack of a better word, but it's a Polar Stretch 300 little hood that you wear underneath that latex seal. You have to have something underneath that latex seal so you can create an air pocket so you can clear your ears. All right. The last thing you want to do is put a latex hood on and not put anything underneath there to create an air pocket. You run the risk of blowing out your eardrums. That's bad. So we talk about full encapsulation, latex hood. We're going to add a hoodie there so you can not only add a little bit of warmth, but it also gives you an air pocket so you can clear your ears. The other thing it does is it also, with a full face mask, and it's kind of hard to see him out there in the right, but the diver in the water's got a full face mask on. Not any part of his body is touching the water. He is fully encapsulated. He's wearing zip gloves. He's wearing the latex hood, the mask. Every part of his body is completely enclosed within that suit. All right. The breathing system also must have a watertight connection, mechanical connection required for severe contamination levels. Gloves also must be mechanically attached to the suit as well. We have two types of gloves. A lot of the public safety divers use the gloves with the dam. what I mean by gloves with the dam is it has a latex seal on the inside of it. So let's say a public safety team is looking for evidence, a car battery, or they're trying to pull a car out of a lake. If they accidentally, because they're using their hands to grab stuff and to feel for stuff, especially in low vis, if they accidentally prick one of their gloves or accidentally puts a hole in one of the gloves, their whole suit does not flood. Okay, again, you're now minimizing the risk to the diver by eliminating a full flood and also eliminating or not exposing his entire body to whatever you're diving in, especially I'm thinking more of the chemicals part of it. So there are different types of boot configurations. Most public safety teams use the rock boot. Performance requirements, we're going to talk a little bit and I'm going to show you some numbers. I'm not going to go through all the statistics, but I will show them to you within this presentation. One is the focus on performance requirement is permutation is key. Okay, and what is that? What is permutation? The ability to have a chemical or more move through the material at the molecular level. Okay, components need to be tested, focused on chemicals with a proven track record, and allows for greater consistency and less liability. The biggest part of the performance requirement, the last 2 or 3 bullet points, just kind of talk about different types of chemicals. And, obviously we can't, there are certain chemicals we're more familiar with. That's probably the best way to put it. But performance requirements are all focused around the permutation and how the chemical affects the suits. These are some statistics about permeability. All right. And as you can notice in the left-hand side, we've got material tested. If you go down on I believe that's the x-axis, material TLS 350, Viking Pro, CXO. The CXO is our fully contaminated suit. We've got the Viking up there, and then we got the TLS 350, which is also our suit. And acetone, that's 180 minutes before that material becomes permeable. 60 to 64 minutes, and then 480 for the CXO. I'll talk a little bit more about the suits, but obviously the CXO is our full hazmat suit. Okay, you can look at the data here with the different types of chemicals and how they affect the suits, and it kind of gives you, it gives you the actual minutes within fermentation of the suit. So I'll give you.
Can I interject a little bit here?
Absolutely, yeah, go for it.
Okay, what we're looking at when it comes to the permeability, now you're not going to be diving and entering the water in a situation where it's going to be pure gasoline or pure acetone, even if it's 10%. Most of these contaminants float on the surface of the water. And what we're dealing with on this point is to making sure that the diver can get underwater as quickly as possible. Mm-hmm. And when they're in the mid-water column, there tends to be less contaminants. Most of your contaminants are up on the surface, yeah, or in the mud on the bottom. And that's the reason why you're looking for dry gloves. You're reaching into all that muck and that ooze, particularly if you happen to be going through a situation where you're in a harbor or you're near an industrial waste area, a lot of heavy metals at this point. You want to protect your hands. It's not necessarily that you're going to have a problem immediately. The problem with chemical contamination is that it actually builds up over time. These wonderful people, men and women that work in this type of situation, could be doing this for 10 or 20 years. And it's not that 1 or 2 dives. It comes up over time. Yeah. And these folks have the highest rate of cancer in public safety. So we're trying to protect them as much as possible. And that's why one of the parameters, if you're looking at the public safety, it is a go or no go. You can reach a situation where it's just like, you don't have the gear, you don't have the experience, you don't have the manpower to back you up. And this might wind up being a dive that a commercial diving company has to go through. So Jay, I'll step back now.
No, excellent points. Excellent points. So types of contamination out there. I mean, like Pete said, most of these are at the bottom, sitting in the silt or floating at the surface. But biological, the most common type is human and animal waste. Pathogens associated with E. coli, hepatitis A, typhoid. None of those look fun. Those are toxins produced by organisms such as red tide. We'll see the red tide out here, and yeah, it gets, the bioluminescence are really pretty, but there's also a lot of biohazards that go along with that. So those are types of toxins. Divers should be vaccinated, usually recommended for healthcare workers, including hepatitis A and B. And, the biggest thing, which Pete just alluded to a second ago, is 80% of all public safety divers have experienced some type of illness related to contaminated water. That's a very high percentage. I mean, I'm not talking just cancer. I'm talking 80% of public safety divers have experienced illness and related contamination water. So, that's one of the drivers behind our suits and keeping the divers safe. So, what are chemical contaminants? All right. So, one of the most likely contaminants divers will usually encounter is a concentration of hydrocarbons, pesticides, anti-fouling plants, oxidants and corrosives such as chlorine and batteries. Imagine a battery that they're going. A lot of times people in lakes, in quarries, a lot of that stuff, they'll dump old batteries in the lake, and that acid just tends to seep out after time. So a lot of the stuff from the garbage from batteries and stuff like that can also add a lot of those different types of toxins, which if it got onto your skin or you somehow ingested that would prove to be very damaging to yourself. So different levels and addressing the needs. Moderate contamination. So what moderate contamination is water that are elevated levels of chemical and or biological contaminations are anticipated to be found. So to possess moderate health risk to the rescuer if not properly protected. One example would be battery recoveries or vehicle recoveries. I know I just kind of talked about it, but with the vehicle recovery and the batteries, golf course ponds, farm ponds, drainage canals, but even body recoveries. I mean, that's not a fun job for anybody, and God bless the guys that go down there and actually have to do that. But if the body's been down there for 2 or 3 days or a week, you can imagine it's a pretty nasty job to have to be able to pull that body up and get closer to their loved ones. So all things to consider. Again, that's everybody comes home safely, and it talks about evaluating the risk. Pete just said it. It's usually a go or no go. So going into our suits, actually, before I go into the suits, Pete, did you want to add anything to that?
No, you pretty covered it, but that's what most of the public safety divers are working with. They're exposed to that. That's what most of the teams, and I work with I'm in Virginia Beach. I work with a lot of the local teams. I do some training with them also. And that's why everything is full encapsulation. So that their most popular suit happens to be the public safety TLS. And I'll give Jay a little bit of a break because we've been talking him to death today. So we're looking at that. It's patterned after the regular TLS suit. And this suit, it is self-donning, has a telescoping design. We talked all about this before. And it is available in a select or the signature series. You can change the colors, and it's a different pattern. There's no real, the overlay isn't the same on this type of suit. You'll notice that the brass zipper is actually exposed, and that's by design, because the overlay that protects that zipper for a sport diver actually will hold contaminants, and it's very difficult to clean. So we need to keep that open. You could change the boot style that's on there. It's got reflective tape is included. You can add all the features onto this suit that you could on a regular TLS suit. You can add a butt pad, you can add knee pads, elbow pads, crotch pad, whatever you need. And most of the teams that I wind up outfitting usually go for butt pad. Why? Because the safety diver and the 90% diver usually wind up in a sitting situation, and they might be there for a while, and they're not necessarily sitting on a padded chair. They might be sitting on a log. They're sitting on a rock. That it'll extend the life of the suit in order to protect them that way. And it's designed for moderate level contamination, which most of our dive teams wind up going through. Those NFPA standards that you see written on there is actually, you can just Google that and get the entire standard if you want it. So it's a suit that does the job for what they need for moderate contamination, providing they are using the hood neck combination and the attached gloves. And remember, these are zip seals. They are replaceable for the teams. And one of the most popular things for these divers is that in some cases, teams will actually be sharing suits. You might have 2 or 3 divers wearing that extra large suit. One guy has a size 10 foot, next guy has a 12, and then someone has a 14. They'll use rock boots. They'll have the Neo sock on there, and they'll be able to change the boot, but their foot will still be dry because there's a sock on it. And back to you, Jay.
Exactly correct. And for everybody, just this is probably one of the more popular suits. We're going to go into a little more features in addition. But one of the things to notice on this suit is there aren't any pockets or knee pads. You can definitely get those accessories added. I've got quite a few teams in the Midwest that do add those. But the one thing, especially with like our armored knee pads, which has got that grain to it, anything with that kind of grain is harder to decontaminate, which we'll talk a little bit about in next few slides. But those are kind of some of the options that you need to consider when you're talking to the teams or you're part of the team, is what kind of rescues or what kind of public safety diving are you actually doing? And that's all part of the risk assessment. All right. So what is severe contaminations? So we've broken it down to moderate, and now we're going to talk about severe. These are the two major elements of public safety diving. So by definition, severe contamination, grossly contaminated water with highly concentrated chemical and biological contamination. It poses an immediate and severe health risk to rescuers if they're not fully encapsulated. So what would this be? Fuel slicks, industrial chemicals, people who are working in shipping yards where there's a lot of boats and a lot of those, the big containers coming through, and a lot of the cargo ships, aircraft, highway incidences, railroad. Those are all things that, kind of fall under the severe contamination definition. Fuel slicks probably being the most popular one. Industrial chemicals, that kind of stuff are just definitely what most divers are going to experience, especially when dealing with ports or bay areas where there's a lot of boat traffic. For that, we use our CXO. Our CXO is our fully contaminated, diving to some really nasty stuff dry suit. It's made of entirely polyurethane. It's the most often used where significant contamination is at least suspected. This comes in 15 select sizes. We do offer it in signature, so we can have it custom made. But like Pete alluded to a little bit earlier, most dive teams do not go signature. They go with standard sizes because it fits a multiple level of, it fits many divers. Okay, a lot of divers out there can use it, especially if they've got turnover. Comes standard with zip gloves. It comes with the zip neck hood combo. The hood liner, which I talked about earlier, that's going to allow you to clear your ears and create an air pocket. The polyurethane zipper and contaminated water valves. You will take notice of that picture. You have yellow valves on there, both exhaust and the yellow inflation valve. Those valves have what is it? It's a separate, it's a double layer of silicone, which helps slow the permeation down so water doesn't leak in. So the exhaust valve's got a double layer of like a silicone diaphragm, which kind of helps prevent and slows down the water entering the system. So if they're coming up from a dive or low and they've got to dump some air, you don't want any of that water accidentally dripping back down through the valve or having that valve burp and get some of that material, especially at the surface when you come up. A lot of that air expands, and guess what's happening as you come up and that air is expanding? It's exiting the suit through that exhaust valve. So if it burps or anything like that and get a little bit of water, we want to avoid that. So we actually have special valves. They are yellow, and that is inlet and the exhaust valve on the suit. It's got excellent permeation resistance on chemical, including hydrocarbons. If I can go back a couple slides if everybody wants me to, but it has all of that broken down by minutes. So it comes in rock boots. It does not come with an extra type of boot because this is a suit specifically for heavy contamination. We do not offer other features like Ultraflex boot or the turbo boot. You get a sock and it comes with rock boots. You don't have a choice. All right, so let's talk about some key elements that kind of help put public safety in the forefront. There were two pretty significant events that happened. Most of you guys have already heard about this or at least know of it. Hurricane Sandy and Katrina changed the perspective. Go ahead and take a look at that picture on the right. Can you imagine how much oil from the cars, tar, streets, all of that stuff's floating in that water right now. Swift water rescue and flood rescue kind of got thrown into this, which we're actually going to talk about swift water in a second. Dry suits alone are not necessarily for flood, for the flood rescue, which is why we're going to talk about our H2O suits, which is going to be a breathable material. It will not pass the permutation testing because it's a breathable fabric, but it's designed for being in the water for amount of times, gives you some level of protection, but it comes in a couple of the dual mode and surface mode, which we will talk about right now. So the DUI H2 op suit, it is yellow. Notice the reflective tape. This one happens to have a relief zipper on it. This one is set up for surface and surface only. Because it comes in surface only and dual mode, we can actually take the exhaust valve and the inlet valve out and put a plug in there, and which is what you're seeing right there. If you look at the chest of that suit, you now have basically a blanking plug. So it's just this suit right here is set up for surface. Interchangeable with regular zip seals, apex valves, adding knee pads, shin pads, butt pads, elbows. You can choose your different, you got a little bit more flexibility here than the CXO, your choice of sock and boot. And again, it's a breathable material, so it doesn't really have any permutation results or statistics against it. In fact, there is none, but it's designed for the swift water, being in the rivers, creek beds, try to keep you warm. You've got different types of seals on it. You've got Neo splash seals.
Real quickly, you said it's breathable or non-breathable?
Non-breathable.
Okay, you're saying breathable.
Then I'm talking too fast and I forgot to say non. Yeah, it's non-breathable material. Sorry, guys. I do tend to do that, so slow me down as well. I tend to start talking relatively fast, so please slow me down. Again, the H2O op suit is pretty much what you're looking at. The seals that you're on there, I believe, are the Neo Splash seals. You cannot go below 5 feet of water, otherwise you will flood your dry suit. They're designed to keep the water off of you, keep you warm, keep a little bit of water, but it's not in dive mode. If you were to switch this to dive mode, you would add an inlet valve, you would add an exhaust valve, and you would swap out those seals to either latex or silicone seals. All right, what are the risk assessment and invisible dangers? So let's talk about challenges. Challenges in conducting reasonable risk assessment. Not everything is visible, or risk can be invisible. Dissolve in water, hidden in sediment. Additional risk could be the increase depending on weather conditions. Definitely a key factor there. And then long-term, making it difficult to assess. Or to assess. So in regards to the last one of the things that you got to take a look at is if you're doing a body recovery or if you're searching for evidence, what are the environmental factors? Are there a lot of tree branches down there? Part of me thinks, and this is kind of Pete's territory, but Florida, the mangroves. What elements are you facing before you go ahead and you make that dive? You need to assess all elements of the risk before you put your team in there or you put your diver in the water.
Jay, you want a break?
Huh?
You want a break?
I'm good, but if you have something to add, you're more than welcome to add to it.
No, I'll come in later with the decontamination.
Okay. So parasitisms, a non-mutual relationship between organisms of different species. Organisms, parasites, they benefit on the expense of they benefit at the expense of others. So now we're going to talk about parasites, and this can get kind of gross if you think about it. But we're talking about invisible dangers that could actually get into your system. And right now we're looking at, I believe it's Giardia, Giardia. And we're talking about one of the common factors on how it's ingested, and it can really tear up your lower intestines and your insides. So I'll give you a couple seconds. It's a nasty looking parasite there, but this is something that tends to, especially if the water's stagnant and there's a lot of biocontaminants in there, these are things that tend to live in those types of water. There's a diagram to the right, which kind of shows the natural progression. I'll leave it here for a second so you can kind of take that in.
And that's one of the main reasons that public safety divers use a full face mask, so that they're protected at that time, not accidentally ingesting the water that they're swimming through. That's the protection. And even when they're on the surface, they keep that mask on. For those of you who don't know it, that they don't use a snorkel, commonly known as a tubular annoyance. They actually have a valve on the sides. It's a surface breathing valve that when they're on the surface, they'll open it up so they're breathing surface air, not necessarily using their scuba air at that point. But if they know they're in an area where there's a lot of fumes and such, they won't use that. They'll stay on the surface air, the scuba air. And the other thing you have to remember too, most of these folks have to work in zero visibility. Mm-hmm. So their dive times tend to be less, for the plain and simple fact they can't see their pressure gauge. So they're limited on time. They're usually tethered on the surface, and they come up when they get that tug, hey, it's time to make the ascent at that point because it's low vis, but we want to make sure that they're not ingesting any of this water. Back to you, Jay.
Exactly. All right. So, went too far. All right. So the challenges are the invisible dangers. Pete and I kind of just talked about all this stuff. So a couple more illustrations, but talking about how this stuff can really tear up your intestines and be very, very painful. All right. Challenges and invisible dangers. Also hepatitis A, B, and C. There's a couple visuals of what this stuff's actually doing to you. All right, so health effects of selected chemicals. So some of this, I'm not going to go through each and every single one of these. You're more than welcome to kind of read through it. I'll leave the slide up as we kind of go through it. But these are all different chemicals that, that we kind of know of what the health effects would be. One of them is, let's see, let's just pick one. Methanol related to coal, natural gas production, as well as a byproduct of the waste breakdown. So high toxicity through relevant and relatively slow acting can cause confusion, dizziness, and blindness. Not good things you want on a dive. Let's talk about acetone trial. Did I pronounce that right, Pete?
Oh yeah, put me on there.
Okay. Yeah, sorry.
Well, there is one thing I'd like to interject, Jay.
Yeah.
I mean, we're basically looking at these particular chemicals, which you'd actually have to water tested to know exactly what's in there. I know of a team down south that actually has tested every body of water within 100 miles that they're responsible for, and they know what's in there before they even show up. But for those of you that are into public safety and you probably threw your pen across the room because you can't write this fast, that's fine. This exact presentation is on DiveDUIUniversity.com. So even though we're going through it now, you can go back and look at it at your leisure at that point. And by the way, public safety divers, there's a test at the end and you will get a diploma. So you can go back to the command and say you've taken some advanced training. So the point that we're making here is that all these chemicals are not going to work well with the human body. And we're just reiterating on mitigating the exposure. Let's face it, the only way to eliminate the exposure, stay home.
Stay out of the water. Yeah. So sodium hydroxide and sulfuric acid, both corrosives and commonly used by many industries. Some of these words I don't use a whole lot, so I'll be honest, they're tough for me to pronounce. So I'm not trying to butcher them. But at the same time, solvent and plastic, pesticides, leather, these are all examples of what could go wrong on a dive. What's in that water that you may not see. And as you can see, and looking at some of the effects and what you're actually in, you can see where, this would be very, very hazardous to you. Okay, so let's talk about some implications. We just talked about the hazards. So all divers face some level of contamination, okay? Anybody, vehicle recovery, even if it's in clean water, there's some risk regardless of the base level of contamination. You want to make sure your equipment is appropriate and anticipated for that level of contamination you face. Again, this comes back to your environmental assessment, assessing your dive site and knowing what you're getting into before you actually go for the dive or go on the dive or send your divers in. sometimes going on the dive isn't the best decision. And it's a go, like Pete alluded to before, go or no go. Sometimes the best decision is not to dive. And then the other question is, are you not properly equipped or trained in contaminated water? So if you don't have the equipment, there's no reason to push it and force a dive if you don't have the proper equipment. Wait until you get the proper equipment and then go for the dive. All of these assessments, guys, will be made by the public safety team. I mean, I'm kind of going through them as part of this public safety division and our suits and how they help public safety divers. But a lot of these decisions are actually going to be made by the command. A couple more: risk contamination without proper decontamination. So when you get out of the water, can you appropriately decontaminate the diver? Swift water, high flow, high abrasion, ease of movement. Flood waters, again, high abrasion, contaminate resistant, lightweight. Thermal stress, how cold or how warm the water is. Those are all things to consider. So when considering contaminated water, there are no nationwide standards for hazmat diving. There is no overall guideline. There's no dry suit approved for contamination waters by an independent certifying agency. What we're doing is we're eliminating risk. We can't eliminate it, but we can reduce it. We can create the probabilities that the divers are going to come back safely. Here's a couple other just quick statistics for you. NFA or NFPA 1670 complete encapsulation recommended. FEMA recommended the following NFPA guidelines, most non-military guidelines. The Navy has extremely strict guidelines for salvage divers. And then NFAPA 1953 addressed specific equipment requirements for contamination water. So those are a couple of the recommendations and some of the stuff that's out there. How does contaminants find a place? So I kind of talked about this a little bit. Spraying equipment with water before the dive is always a good idea, especially when you're looking at that material. If you've got arm and knee pads, or you've got if you're diving with a TLS 350 and you got cargo pockets, well, you have Velcro on those pockets because that's how those shut. So you've got you got Velcro that's got the pile that can get contaminated in there as well. So there are many decontamination procedures, and some are more effective, but they also lengthen the service of the equipment. If you can imagine, if you even, like Pete said, gasoline's at the surface. Well, you may not be there for very long, but over 50 dives being exposed to those kind of contaminants will eventually break down the suit and damage your equipment. So it has to be maintained, it has to be cleaned, and it has to be evaluated almost constantly.
Jay, could you coming up on this and where this came from? I was talking to Dick Long and folks, Dick's got a history that goes back. It starts at 1963. And I asked him, I said, how did the oil field divers climbing through grease and oil actually get their gear to last longer? Because most of the stuff we use for decontamination didn't exist back then. It was like, oh, that was easy. We hosed them down before they entered the water. The whole idea was to fill the gaps up in between all the nylon material. So once you wet the diver down and they jump into the water, the gasoline doesn't replace the water that's already in the nylon pile. So you're going to get in the water quickly. You wet it down. All you get, and this applies to your BC too, because that's got a nylon outer bag for most of you, and they're going to wind up getting in the water. The difference is when they come out and they decontaminate, the decontamination procedure is a lot more effective because most of the area in between the weave has been filled up with water, and now it just basically sloughs off at that point. And by the way, how well does this work? Well, if you're an instructor listening to us right now and your gear is starting to turn brown from being in the pool, your gear's not breaking down. What's happening is, unlike Jay, whose gear is turning brown, is you need to hose it down beforehand, get it wet, take it through the shower, and you're about to jump into an environment that we consider clean, but chlorine is a very corrosive salt. So if you even wet it down before you put it in the pool, your gear is going to last longer. It'll be a little bit more color fast at that point, and that's going to lengthen the service life of all your equipment.
Yeah. All right. So circling back, what are some protocols? All right, this is a decontamination booth. When the diver comes out of the water, we spray them down. This is a 2 to 3 minute shower where the diver and the equipment are progressively clean. You'll notice how he did not take off his equipment. He's still wearing his dry suit. He's still got his rig on, and he's standing in basically in a shower, makeshift shower.
Well, let me interject one thing. Technically, this diver is not decontaminating himself because he took his mask off. So
Yeah.
while he's in the shower, he's doing 2 to 3 showers. He's actually spraying whatever on his hood's going right on his face, possibly into his mouth or up his nose. So when you're decontaminated, you stay fully encapsulated. And the other thing you have to be aware of too, when you're decontaminating the diver, the tender has to be aware of the splash off at that point. They have to worry about getting contaminated also. With some of the chemicals that you're wearing, they are really harsh. So he's actually standing in a kiddie pool, and that water that's blown off his suit is actually a contaminant. It's supposed to be put into some sort of a barrel and then taken off to the dump where it's going to be taken care of as a contaminated effluent at that point. So you don't clean the diver off and then dump all that soapy water back into the waterway. It has to be actually gathered up at that point. And you can see some of the chemicals that are listed here that have been used. There are some specific for this, but they're really expensive and they need special equipment in order to work with them, and they're difficult to find.
Yeah. So, yeah, exactly right. Typical cleaning agents, they're right there. Antimicrobial soap, 5% bleach, trisodium phosphate, simple green, just to name a few. All right, so what are some limitations of current decontamination? Environmental impact, we just kind of talked about that. Contamination requirements, general large volumes of waste. We've got effect on a diver, support personnel and equipment. Bleach, TSP can be corrosive and equipment hazardous to your person.
TSP is trisodium phosphate. It's illegal in a lot of states now.
Oh, is it?
Yeah.
Effectiveness, bleach 10 to 20% concentrated required for guaranteed effectiveness against any biological or chemical contaminants. Antimicrobial soap requires copious amounts of water and extensive scrubbing for high effectiveness. Does not neutralize contaminants as much as it removes it. And then again, this is just kind of labeling simple green, not effective against broad spectrum of contaminants. And all of these contamination solutions require significant cleaning times. In other words, it's not, just don't jump in, hose down. It usually takes a couple of minutes. So, all right, definitive contamination and post-dive evaluation. So this is all about protecting your gear and cleaning your gear. You want to scrub the unit with the cleaning solutions with plenty of water. Use a toothbrush, and clean this. Go through the zipper, flush it with water, fresh water. Go through the valves, hose off the valves a little bit. Try to get into all those nasty little places. Latex seals, check for deterioration. Okay, latex tends to dry out, they crack, they can become permeable. Not good on a dive if it goes through it. So you want to make sure you wash those thoroughly and replace those as often as you possibly can in order to protect yourself. If there's any suspect, if you think there's anything wrong or high susceptibility to contamination, go ahead and clean it thoroughly. If not, replace it.
And the one thing we don't use with these suits, you don't use silicone seals. We don't make the hood neck combo in silicone. Everything's made out of latex. Silicone will absorb more of the contaminants. It shortens the life. And it'll actually almost go through the silicone and right against your skin. So that's why we use latex on all of the suits.
Correct. Yep.
Thanks.
All right, so just in summary, public safety divers encountered chemical and biological contaminants. The public safety divers, the idea is to mitigate the risk. Obviously, we cannot eliminate risk entirely, but the idea is to manage it better, protect the divers better. We do that through full exposure, full encapsulation, having the right dry suits and the right testing to support the suits for the team. Choosing the proper exposure for the environment that you're in. Pre-dive rinsing, taking care of your gear, Decontamination is critical for the protection of the diver, support staff. And really, again, circling back to my primary statement when I first started, it all comes down to the safety of the diver. It all comes down to everybody comes back, evaluating the risk, evaluating your dive site, understanding what you're going into and why, and making and completing the necessary steps to bring everybody back safely and to go on that op safely and produce it.
And for those of you who are thinking about getting involved in public safety, ERDI is one of the training agencies. It's part of SDI, TDI, and you could take classes in that to get an idea of what goes on. Usually you have to be a member of the public safety team, you know, the local public safety, police, fire. Some teams do work with volunteers, but there is specific training for this type of diving.
Mm-hmm. So with that, I will open it up to questions.
So I don't have a lot.
Okay. Well, we
but,
dumped a lot of information on them.
Sorry. A question about, can you use silicone zip seals?
No,
No.
that's why everything is latex. It's default. Everything is latex. It's not recommended because they won't last for a long period of time. We do have to worry about silicone is hypoallergenic. So it's basically you're going to allow for a lot of the contaminants to move through the silicone right against the diver's skin.
Right, so it's permeable. So that goes down to the yellow valves that you're talking about, Jay. You're saying that they had silicone, so that.
Go ahead, Jay.
Go ahead.
No, I was going to look it up. It is a double layer. The valves that are in the all the sport diving suits and the TLS 350, it's all a sport valve that's in there. So there's a double exhaust diaphragm and a check valve made from fluorosilicone, which is a different compound to minimize the risk of exposure to combination. Okay. Now, where does this go with those valves is, you know, they won't last forever. And if you're really going into some gnarly stuff, those valves need to be changed. So it's not something that, you know, that valve is going to last the life of the suit when you're diving with oil, grease, any type of the contaminants that are there to protect the diver. You really can't rebuild these valves. It's when they're done. They have to be replaced.
A question on the CXO. Why can't you put boots on?
Because it's fully contaminated. It's our base. The CXO suit is for highly contaminated water, and all of our boots have neoprene in them. Our turbo boot, Ultraflex boot, our Turbo Tech boots got the Armid on it, and because those tend to attract and absorb chemicals, we will not put them on the suit. The suit is rated the way it's rated because we put it in the nastiest chemicals, the nastiest types of environment, and we want to make sure the diver is completely encapsulated. But also for what we just talked about, as far as decontaminating, standing in the shower for 3 minutes, we need to be able to make sure we rinse off and get all those biochemicals and all those nasty organisms that can cause you harm. We want to make sure we clean you off efficiently. And unfortunately, with the other types of boots that we have, and the nature of the CXO, the suit, it's safer for the diver to have it as one material.
It's also confirming that two different types of material will properly bond together, right, so that you don't wind up with a leak point. You'll have a seam there, which takes the most amount of abuse as the diver's taking the suit on and off. So we're working on that. It's just not available today until we're sure that we can protect the divers.
So going through the decontamination process, there is a guideline for this, and I'm sure it's not just a 3-minute shower.
Well, it's 2 to 3 levels of decontamination to keep the diver clean. It's part of the ERDI training is basically making sure that you have removed all the contaminants. That also includes possibly scrubbing the diver down, using pretty much a soft brush like you would use on your car, in order to make sure that you've cleaned everything, especially the zipper on the suit, to get the contaminants off. I mean, just flushing off isn't going to get the contaminants off. You'll get that first exposure off that's on there, but if it's been an excessively gnarly dive, you may have to scrub the diver down in order to clean it out. So it's not 2 to 3 minutes. It could be longer, and they don't always necessarily put a whole bunch of divers in at the same time if it's really nasty. I've got one team over here that's working in the dismal swamp, and it's dismal. As soon as you put your face in the water, visibility is 0, and it's just full of peat and oil and grease, and they just keep finding cars. So they don't put everybody in at the same time. They get in, they do the job, they try to get the diver to do as much as he can, then they'll move to somebody else. They don't want everybody in, so they minimize the amount of gear that has to be decontaminated.
So I have a question about the H2O ops suit.
Okay.
And that is, how well do the Neo Seals work?
Well, the Neo Seals are designed as a splash guard. They're designed to be worn. Anybody who's been dry suit diving, if you've had your suit on for 2 or 3 hours, latex or silicone, you'll feel it on your neck. You get a little abrasion there. That type of a seal, it's a very light neoprene. It's thin. It acts like a splash guard. It's called the dual op suit because one function of that suit is so that you can actually use it for surface swimming, for swift water rescues. But if you're going to be sitting on a boat for 4 or 5 hours, that's the next seal you want. I have a team up here in Hampton. They use those suits because sometimes they'll be doing an operation where they'll be working off the boat. They want the divers wearing the topside setup, so they don't have the valves in it. They're just using the splash guards. But the other side of the team has taken off those splash guards and put the regular latex seals or dry gloves with the attached hood onto the suit.
And the Neo Splash seals will not, you can't dive them. As I understand it, you can't go below 5 feet before they start to leak.
Right. They'll be comfortable, but you'll be wet.
Yeah.
So that's, I mean, those are the main questions I have right now, other than when you get decontaminated, when you said a sock with a rock boot, how do you decontaminate the rock boots?
Well, the advantage and the cost effectiveness of the rock boot is you throw them out, but it's cheaper than buying a new CXO suit. So the question's valid, and you're right. You don't decontaminate the boot completely, but it's also one of the cheapest parts to replace.
The only other thing that, I mean, I guess I would probably interject is that on the CXO suit, you can get it with the yoke option, which I have not done myself, which allows you to add a Kirby Morgan hard helmet for surface applied air into the suit.
Yeah, there's a few teams that will go that way, but they happen to have a yearly budget that allow for it. And that's a different type of diving, different type of training. You're now at that point where you need the skills of a commercial diver. You need the backup. You need the supply in order to make it work.
Right. I have a friend that is actually, I would call him a poo diver.
Okay.
He's actually had to do that with a CXO. Well, I don't know if it's a CXO, but it was a CXO suit with the helmet with the yoke system, surface applied air. I personally would not like to do that job.
Sometimes it's fun to watch.
Other than that, I think that's all the questions I have for right now. And we're close to our ending time. So I just want to remind everybody, tomorrow we start again at 10 o'clock a.m. Pacific Standard Time. Tomorrow will be all about OMS. I'm sure we'll talk about some DUI stuff in there throughout the day too, or answer any questions that people have. Tomorrow it'll be Pete. So Pete, make sure you get plenty of rest tonight and trim the beard or the mustache so it's just right. So you look good on camera tomorrow. Anyways, so thanks everyone for coming out today. And we look forward to seeing you out here tomorrow with our virtual trade show from DUI. So thanks everyone.
Thanks, guys.
Thanks, guys. Have a good day. Can I leave now, Jack?
Anyways, just so everyone sees the screen for tomorrow.
Oh, okay.